Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and we are starting to get to the end of this chapter of analytical geometry. But before we get to the end, there's two more videos, this one and the next one, where I'm going to go through an exam question on each video. So this might be a bit longer than the previous videos, or actually I know it's going to be quite a bit longer. But I'm asking you, stay with me, because this is definitely some good practice for you. So I'm going to encourage you to take this question, pause the video, try it yourself. Once you've done it, you come back, watch over it, make sure that you get the right questions or the right answers as I'm going to get. So I'm going to start with question 1.1. But before I get there, let's go through the information. In the sketch, the line CD has an equation of y equal to x minus 12. So that's CD. The figure ABCD is a trapezium with AB being parallel to CD. I like to put those things in on the sketch. B and D lie on the x-axis. It is given that BC is perpendicular to CD. Now I'm just going to put in one or two extra things. Because they lie on the x-axis, I know that the y values are 0 for both B and D. Please put in the information as it is given to you. So let's go through the first question, question 1.1. If C is 2, y, determine the value of y. Interesting little question that. So what I'm going to do is, because I have the equation of the line passing through C and D, I am simply going to take that x value, substitute it in, and ta-da! I've got the y value. As easy and as simple as that, ladies and gentlemen. Do not forget that if you've got an x value or a y value and a line, you can just substitute in to get the other coordinate. Now at 1.2, this is awesome, because actually I can now see that 1.1 was right. 1.2, if C is the set of coordinates 2, -10, determine the equation of BC. Now please don't forget that they also gave me BC is perpendicular to CD. So where do we start? Well, we start by an equation. I need a gradient and I need another set of coordinates. I've got 3 options for gradient. As you know, if you don't know this, rewatch the previous videos. I don't have C and D, so I can't use the first one. I don't have parallel lines. Well, I do, but that's with AB, not with BC. So I'm not going to use the second one, but I am going to use perpendicularity. I'm going to use that third option. And because the gradient is 1, now I've already gone and quickly calculated into, but I want you to just be aware that that 1 comes from being the coefficient of x. If I substitute that into there, I can calculate my M2. So this means my gradient is -1. Going further, I'm going to go and substitute my set of coordinates 2, -10 in, and I'm going to calculate C. So my C value is -8, which means that my equation is y equal to -x minus 8. As easy as that. What I'm going to do is, as soon as I've got something, I fill it in on my sketch. Because I don't know where I'm going to use it next. So let's go to question 1.3. Now at 1.3 it says calculate the coordinates of B. Remember what you did earlier, just previously in 1.2. I now have the equation of BC. And B is specifically the x-intercept of BC, which means my y value is 0 as we hinted at earlier. But I don't know what the x value is. Again, I can substitute because I have the equation of BC. I make the y value 0 and I solve for x. So B must be -8, 0. As easy as that. If I'm going a little bit fast for you, let's just rewind for a moment. If I rewind for one moment, I start off by looking at the equation of BC. Y equal to -8 -x minus 8. Substituting y to be 0, because I know at B the y value is 0. I solve for x and I've got it there. Writing it in on my sketch, I now go to 1.4. Determine the coordinate of E if E is the midpoint of BD. This is straightforward, or so it looks. If I'm going to calculate E, I'm going to go to my formula. But the beautiful thing is, because both B and D is on the x-axis, my y values are 0. So the E value, the y value of E is automatically 0. If I now look at what I've got already the y value, but I need that x value of D. I don't have that. But I do have something else up my sleeve. I have that line, y equal to x minus 12. And D is on the x-axis, so the y value is again 0, so x must be 12. Which means E is -8 plus 12 over 2, 0. If I calculate that, my answer is also 2, 0. If I went a bit fast again, just backtrack a little bit. I needed the x value of D, so I again got the x-intercept of the line CD. That then I used and substituted in to the midpoint formula to give me E's coordinates. Wow, this is beautiful. It looks so simple, but sure, it is beautiful. Now let's look at the last little question, last two questions. If E was the midpoint of BD and AC, in other words, if that was the case, meaning that it was that diagonals bisect each other. You see what I did is I took it out of the sketch and I just roughly drew what I understand. If that was the case, what type of quadrilateral must ABCD be? That sounds really interesting, ABCDB. Well, it would be either a parallelogram, a rectangle, or a square if I wanted to. But squaring that, I'm a bit concerned because I actually don't have enough information that all the sides are equal. But I can say maybe a rectangle because there's a 90 degrees there. What would be the reason? The reason would be that the diagonals bisect one another, and that happens only at parallelograms, rectangles, squares, and rhombi. So let's have a look now at 1.6. Determine the area of triangle BCD. Now the area of triangle BCD, that is a normal triangle. But please be careful. Look at the mark allocation, 5 marks. So this is going to be quite a bit of work. Let's start with what is the area of any triangle. The area of any triangle is a half base times perpendicular height. To make life easier, I drew that triangle, this triangle apart, so BCD. I split it from the rest. Drew in my 90 degrees. Now I think if that was a normal triangle, not on a Cartesian plane, what would be the area? Well, a half times base times perpendicular height, with the base being CD and the height being BC because it's right next to the 90 degrees. Would it have been any different if I swapped those sides around? No. No, it wouldn't. But please, BD is the hypotenuse, so that has got nothing to do. BD has got nothing to do with the area. So this means that I actually need the lengths of the sides of CD and BC. Oh, but wait, that's why it's 5 marks. Using the formula for the distance between C and D, I get an answer of 10 root 2. I'm not going to worry about the decimal value, but I'm going to repeat the process with BC. Using the distance formula, I've got BC as being that. So actually, interestingly enough, and this has got nothing to do with the sum, but BC is actually equal to CD. What type of a triangle could it be? It's isosceles. So this could have been another kind of question. Classify your triangle according to the length of the sides. Well, this would be an isosceles triangle. Hey, but I'm getting sidetracked here, so let's get back to the question. If I substitute those values in, then the area is a half times 10 root 2 times by 10 root 2 for CD and BC. Putting it into my calculator, I get 100 units squared. Would they deduct marks if you don't put the units squared there? I seriously doubt it. But, and I'm saying this with a big but, your teacher might just say, I am going to deduct marks. So please go and find out from your teacher what is their stance on this. What a absolutely gorgeous question. This is a very typical exam type question you could expect in your exam. So if you again want to go over the video, go for it. It's worthwhile. But tune in to our last video in this series of coordinate geometry. Looking forward to seeing you guys soon. Keep well. Cheers.